Chances are you have a set of simple rules or principles you use to guide yourself through daily life. Have you ever stopped to question the origins or legitimacy of those principles? In today's episode, I sit down with a dear friend of mine and fellow undergraduate student, James Squires. James is currently pursuing degrees in mathematics, physics, and computer science. This is Thought and Theory, a podcast dedicated to exploring the intersection of philosophy and science. Please enjoy. James, pleasure to have you.
Howdy.
Um, what is an axiom? Why should people care about axioms?
No difficult questions right away.
Light question to start.
Yeah. I think I'm going to start with a bit more motivation and maybe some examples. I'm going to do it through a mathematical lens,
Okay.
and then maybe we can move more into like a general propositional type deal and like philosophy.
Mhm.
Understanding how an axiom works mathematically can help you understand how it works philosophically,
Yeah.
I think.
So is it fundamentally a mathematical thing? Like, is it an object? Is it like a rule? Like,
It, it's fundamentally like a propositional logic thing.
okay.
So that can even be just a philosophical thing because philosophy kind of pioneered that. Like you have certain Stoics who were inventing propositional logic back in Rome. But it's very like our understanding is more robust around axioms because of mathematics.
Okay. So that was like the primary field that implored them to.
Yeah. Our understanding of axioms evolved from geometry, from number theory. I can get into that, but as far as what an axiom is, basically it's an assumption you make for a system. So you need to start somewhere if you're creating a formal logical system. You start with the axiom. So in math, we have this idea of proving things, like one thing implies another thing. Um, with axioms, you don't have any implication for them. They're just there. And then you
Okay.
use those to build the implications. So maybe an example would be like with Peano's axioms, which are basically the axioms we use to define the natural numbers.
Okay.
So, uh, in order to build up things like calculus and even just number theory, we need to start with some axioms, and Peano's axioms are a popular choice. Basically, the axioms go like 0 is a natural number, and then an increment of 0 is also a natural number. By increment, I mean basically adding 1. And then if you increment a natural number, it can't bring you back to the previous natural number. So if you add 1 to 0, you get 1, and 1 cannot be 0.
Okay.
Um,
And there's no. I mean, these things are true because we say they're true. They're just
yes,
our starting assumption that we have to say, okay, something must exist, and then we go from there.
yes, yeah.
Do they hold truth value outside of that, or are they just propositional claims that we build on?
Well, that's more philosophical territory,
Yeah,
right?
yeah, I guess that, yeah.
Like, so why did we choose? By the way, I didn't finish all of the Piaget's
Oh,
axioms.
yeah,
Like,
go ahead.
there are a couple of others. It's not too important. I think it kind of conveys the point. But there's also one about induction where, like, if you have a number n, then you also have a natural number n plus one. So if you have four, then five is also a natural number. And then I might be missing one or two. But
Who
sorry,
is
yeah.
Euclid's elements? Are those like a
Mhm.
point is something that has no, or a line is something with no breadth? Are those Euclid's axioms? Are those what that is?
Yeah. He has 10 postulates, or he has
Okay.
5 postulates and 5 common notions in his book, but those are really the same thing. They're just axioms, they're foundational assumptions. Yeah, so he has a couple. Like, for example, one of the common notions is um, if something is equal to another thing, and that other thing is equal to a third thing, then the first thing and the third thing are equal.
Okay.
So what is that? That's transitivity. It's like A equals B, B equals C. then A equals C. That's one of his common notions, which is really an axiom in Euclid's Elements.
So
Um,
was the entire formal field of mathematics built on these axioms, and we just accept them and go about our daily lives doing mathematics with these underlying assumptions that we might not even be aware of?
Not explicitly just these axioms, like not just Euclid's
Well, sure,
axioms
yeah.
and Piaget's axioms, but yeah, I mean, like all of mathematics is predicated on axioms, and like if we tried doing it without axioms, we'd run into major problems. But um, maybe an important thing to kind of like focus on a bit is why do we have like Piaget's axioms versus some other axioms? So why do we assume certain things versus some other things? Well, this is probably where someone would be like, okay, well, obviously, if I combine one thing and another thing, we get two things. Yeah, I agree. That's why we're using Piaget's axioms. Is like we're basically saying that in math terms, and it's like almost a fundamental truth to us. So it seems like these axioms are the most useful axioms to use because of that.
And is this have to do with just we're humans and we have digits and we say, oh, one thing and one thing and two things, and then we need someone to formalize that so we can then go somewhere with that notion?
Yes,
Okay.
because it's hard to just map like a physical intuition into math. So that's kind of a starting place. They're useful assumptions.
Got it.
Yeah.
And so I do want to ask about like truth and axioms. I
Yes.
know that strays from the mathematical territory, but so it seems to me like the goal of a good set of axioms is to create a system that you can then build something on.
Hmm.
So is the purpose to say, okay, well, we have these fundamental assumptions and we're just going to say that they're true because we need somewhere to start. I mean, it's like a 0 point in a coordinate system.
Hmm.
So then is the purpose of what results from using those approximating truth, or is it like a self-contained truth within its model, or like what's the so we have these axioms that we build a structure with. What comes
Hmm.
out of that? What's the purpose of doing that?
Yeah, so I actually asked a similar question to one of my
Hmm.
professors who
Okay.
I think is very intelligent, and it kind of got into Gödel's incompleteness
Oh, okay. I
theorem.
have that on here.
Yeah, yeah. But uh, I mean, yeah, I think a lot of mathematicians might view this more objectively, more platonically. But this seems like a philosophical thing. So you're
Yeah.
asking if we have axioms and then we have a system that stems from these axioms, does the system demonstrate some type of truth? Is the idea, right?
More so, do the axioms impose a limit on what we can obtain from the system as far as its truth? And the example I think of is like Newtonian mechanics. Like we don't
Mhm.
say Newtonian mechanics is true. It's an approximation because then we can go and learn Lagrangian mechanics and go, okay, well, like
Mhm.
there's these limit cases where Newtonian mechanics breaks down. So that might be a bit of an abstraction.
That's a good way to think, or that's a good way to raise the point. Yeah, I
Okay.
see what you're saying. Yeah, so if you have some axioms, you're right. They need to like produce something. We'll start with that.
Hopefully.
Yeah, this is actually called like okay. The term Gödel uses, I think, is sufficiently powerful.
Hmm.
So the idea is if so you can have axioms, but if you okay, so the idea is that you can have axioms and they'll either not be powerful enough or sufficiently powerful. And what I mean by that is that if your axioms aren't sufficiently powerful, they're not very useful. Like it's not a robust
Yeah.
system. So like specifically, if your axioms in mathematics aren't sufficiently powerful, you can't use your axioms to demonstrate things like basic arithmetics, like 1 + 1 is 2. So that I'm just defying this term because it'll be useful down the line.
Okay. So it's almost like a self, like they contain themselves in the way that you can check them. And if you can't do that, then that's a good sign you can't build anything useful with your set of axioms.
Yeah, you want your axioms to be robust enough,
Okay.
pretty much.
Gotcha.
The other thing you want is for your axioms to be consistent, so they don't produce contradictions, right? So like um, that basically. be like, okay, you start with these axioms, maybe Piaget's axioms, or no, sorry, Piaget's axioms are fairly good, but let's just say you start with some axioms, and then they produce a theorem, but this theorem is both true or false. That's kind of contradictory.
Okay.
So you don't want that to happen.
Yeah.
Yeah.
Is this similar to what you were telling me about the coding language Lean that you're working on, where the goal is to like construct a set of axioms and then prove that they are consistent in the term. Like the goal is to get to an expression that's something like x equals x, where we can say yes, this is true, and we've used our axioms to prove that.
Uh, yeah, yeah. So the goal is to be able to like bring everything back to the axioms at the end of the day. So it's true because it follows from the axioms. But as far as like the scope that you can gain from the axioms, how Gödel's incompleteness theorem is second
Is
incompleteness
that the
theorem.
famous one that everyone is?
Yeah,
Okay.
yeah, he has two. The
Okay.
first one is actually just a special case with the natural numbers and Piaget's axioms, but the second one is like more general
Gotcha.
propositional logic. But sorry, what was I saying?
Oh, well, I was asking, I guess maybe we might go into what Lean is, because I
Mhm,
mentioned a computer programming language that I don't really know anything about. I mean, we were talking
mhm.
about it on the way here, where it's just, I mean, you put in your axioms and you show that they are consistent, and then maybe do something with it. What are you doing there?
Oh, yeah. Well, I'm kind of new to lean, but like this is a super interesting topic. And is like this is fairly like a fairly good example to demonstrate what we're talking about. Lean is a coding language developed by a Microsoft research team, and basically it's a coding language that is designed to formally verify mathematical proofs through code. So what I mean by that, by formal verification, is like we're using computational abilities to um, basically say like what we would say with math on paper. So like the axiom implies this, which implies this, but through the computer. And for your lean code to work, you typically need certain axioms that you have to use to build your implications. It's pretty cool though. I definitely encourage anyone to check it out.
So is this formal verification, does that go for any sort of mathematical proof that you sort of plug it into the system and see if it follows from your set of axioms or the proof set of axioms?
What do you mean go for? Like,
So what I mean, the purpose of what are we doing with Lean in terms of formal verification? Like, is it meant to verify if things are consistent, or is it just to
mhm.
show that like you put in some sort of axioms? Like, what's the use case, I guess?
Yeah, yeah. It's meant to verify like theorems to be true, right?
Okay.
Based on axioms. So yeah, in that sense, it's demonstrating consistency or inconsistency, and that's important. So like, Lean wants to verify what I said earlier, that a system is consistent or that a proof isn't both true or false. Lean wants to verify that a theorem's true. Yeah, you start grounds up with axioms in Lean, and then you code the theorems, and
I
uh,
see.
yeah,
I see.
yep.
Okay. So we I'm thinking about a conversation we had on campus.
Hmm.
Maybe that must have been last semester about like effective communication. And here I'm wanting to move off of the mathematical topic of axioms. And we had a conversation about why we have good conversations and what makes our conversation so productive. And I think the conclusion that we came to is we both are looking for the same thing out of a conversation and not trying to impose anything on it. So is there a role that axioms are playing in a dialogue like that where you need to sort
Mm.
of understand the other person's axioms, at least as it relates to what they want out of a conversation, what they're looking for, what they're trying to put forward? I mean, we had a good conversation about that.
Yeah. So that's there's a lot to unpack there,
Yeah.
and some of it I've been trying to figure out myself. But uh, I'll just tell you maybe uh, when problems can arise dialogue first, based on axioms, and then maybe that can help us
Mhm.
arrive at a kind of conclusive answer for your question. Like, I think a dialogue breaks down when both people who came to the table aren't interested in the inquiry typically, or when they meet at crossroads where they just can't agree on something. It kind of stops the conversation
Like a
there.
fundamental disagreement.
Yeah, yeah, and it's kind of like saying truth values are different, like for a certain thing that they're talking about. And honestly, that typically that is kind of an axiomatic problem. So quite often when people are talking about political issues, there are different types of political issues where like they agree on their like where they want to go. They disagree on how to get there.
Hmm.
Those typically I don't think of as like problematic in the sense that they have a fundamental disagreement of axioms, but where like political issues are tugging at each other, like
Right.
they want to go different ways, there seems to be an axiomatic disagreement. Um,
Okay. And by that you mean that the set of rules or principles that these people use to guide their daily life and decisions, it is almost incompatible with another person's set of rules, and the views or the conclusions that they come to as a result of these set of rules or axioms is not coherent with somebody else's, and that can
yeah,
break down conversations.
yes, and maybe a good example is like the axiom someone like a Christian might take from the Bible, for example, versus someone who isn't Christian. Maybe they're like, I don't know, Buddhist or
Like original
atheist.
sin might is original sin might be a sort of an axiom,
Uh,
the sense that we're all, born in fallen world, and we need, like, because of that we need God. So like there's an axiom and like an initial assumption and principle, and then you derive a result from that, and that can stand in contrast with people when you try to have a discussion about it.
yeah, yeah. I think this would take some exploration to
Yeah.
determine whether, because it seems like everyone kind of has like a system of truths that they predicate their views on, and they're kind of similar. Like the problem is, it's not like people aren't like mathematics in the sense where you
Right.
just have different robust systems of axioms. It's like there are a lot of sets of ideas that people possess that are fairly similar, but maybe they're just different in this way. And then when you take it out far enough, like a conversation out far enough, you end up running into problems.
I would like to ask,
Hmm.
when you're in dialogue with somebody, are you doing like an axiomatic analysis of that person? Are you looking for cues that tell you what their underlying axioms are? I mean, it seems like we have a lot of conversations with our fellow classmates, and
Hmm.
and and you're always the almost the referee, and you're like, hold on, we need to back up here and like find this. And is
Mhm.
that what you're getting at? Is analyzing this axiomatic structure of the people engaging in the discussion?
Okay, so that you actually just brought an interesting idea to mind. When I'm having dialogues, what I'm kind of doing with these questions, um, I think a dialogue has a lot of questions in it. Usually, it doesn't necessarily have to be Socratic, but at least Socratic-esque to be
Right.
high quality. What I'm doing is not probing for their axioms necessarily, but because usually a dialogue that you have with someone about some sort of issue topic, you're already starting like way up here in their system of
Yeah.
ideas. It's like if have a mathematical system like the natural numbers, you're starting up at calculus. So that's what happens with people when you're having a dialogue. What I'm doing is trying to reverse engineer their ideas a bit. So maybe we can work backward until we see where exactly like the bifurcation point happened.
Right. Right.
Yeah, where their axioms differ, or maybe not. Yeah, yeah. So that's typically what's happening with a dialogue.
So you're looking for the place because we can't start deep into our beliefs about, okay, like I have these fundamental assumptions that lead me to these conclusions, and then
Hmm.
I I took those and applied them to the world and analyzed the result. And it's like you can't start at analyzing the result because
Mhm.
we got there from a different structure and a different set of conclusions. So when we're maybe in our undergrad lounge and
Mhm.
having some sort of politically motivated discussion and the people are all engaging in the conversation, going at it from, okay, I have my set of rules, I derived my conclusion, and I interpreted that, and then this is my analysis of this event. And we can't talk at that level to begin with if we don't first dive deep to the set of rules that got us there. Is that
Yeah.
what you're looking for in those conversations?
Yeah, typically, political discourse is like already assumed things that just
Yes.
don't mesh with each other. So, yeah, I'm typically looking for reversing the results and seeing where we can kind of
And people
agree and
don't like that's unnatural. Like that's
unnatural.
well, it might seem perfectly logical, but a lot of times people want to just go and make their point, and I mean, it's not going to land if we
That isn't a
haven't.
dialogue.
Yeah, yeah, that
Yeah,
yeah,
that's what you call a steamrolling contest or something. I mean, I just
yeah,
made that term up, but like I try to avoid those. So if I want to maybe inquire about a thing, like politically, I try to approach it as third person as possible.
yeah.
And if I was, for example, to come up to someone who wants to just like to assert a point, and they're not interested in the inquiry.
Mhm.
That's not a dialogue. It's just the person rolling over me.
So you said I like that term. It's steamrolling contest. So is this prone to occur if we haven't first explored the axioms, or is that a motivation issue? Like how can you avoid that or spot that in a discussion so you don't get yourself into a steamrolling competition with somebody?
Yeah. So I think I think determining whether you have a dialogue or something worse comes from like your directive for the conversation.
Mhm.
So it comes from what you're motivated to do exactly. If you're interested in the inquiry, I think you'll naturally want to be more thorough about the conversation. So you want to ask them maybe something simpler to start out with, and you want to see where they go with that, and you want to see each step. Like that would be typically what happens in a productive dialogue. So if you're trying to do something like that, I think you'll create a more robust conversation. So like finding a very agreeable truth between the
Right.
parties
Right.
and then starting from there. And in a sense, that's like kind of the mathematical school of thought, but like more broad, like broader, it's just like a good philosophical approach to dialogue.
Yeah.
Yeah.
So, is this what people are doing when they try to first open a conversation with common ground, or is this what's happening when you feel like you're talking past somebody because you haven't done that?
Yeah, but well, a good note is that that is what we'd call common ground, is trying to start with the truth that you both agree with.
Yeah.
Yeah, and then maybe seeing where exactly the implications
Yeah.
like differentiate. Yeah.
So we had just mentioned steamrolling, and it's real good to not start at the top of your political beliefs or at the conclusions of your political beliefs.
Hmm.
Um, but if you're not aware of your own axioms, if you're not conscious of what's driving you, and you might be hearing somebody sit down and go, oh well, we want to examine our own axioms and not start from the top. But if that's all you know, because I don't know, maybe you get all your news from X and you just scroll, where do we go to examine our own axioms? Like what are tests we can sort of do on ourselves? Be like, well, what is it that I really think fundamentally?
Mm. Yeah,
Light
so
question, huh?
that yeah, that's difficult because I mean I'm still asking myself that question.
Right. Yeah.
Like that I think the best way to figure it out is to just play with the system that is your school of thought like a lot. So like
Mhm.
you can kind of feel out your axioms by having a bunch of dialogues. I suspect this is the answer. Maybe not the complete one, but
And you do this a lot. Like you make it a point to talk to a lot of people and as a sort of and are you doing this almost as like a test of your own axioms to see
yeah,
how they're
yeah,
of
quite
what conclusions
often.
they lead to?
Yeah, quite often I get into political conversations because I like if I'm being honest, I just don't actually feel convinced about anything, and
Yeah.
I'm trying to figure it out. Like I'm looking for an answer. Um, it's experimental. In that sense is I in that sense it is kind of similar to like playing with mathematics to
Yeah.
figure out what you need to
We're
do.
just all running on a lean program and
Yeah.
trying to figure out if we can verify ourselves.
Um, maybe.
Yeah, right. I probably have more to say about that whole simulatory stuff. So, when it comes to discovering your own axioms, we can often just test them through dialogue to see what comes out of that and what the results of that are, and see
Mhm.
if we can produce anything consistent. And I'm sure there's plenty of examples where dialogue just goes nowhere, and maybe you leave feeling like, oh, well, that went nowhere, and clearly something's wrong with my fundamental assumptions. One of the symptoms I have when it comes to exploring. Oh,
Sorry,
go
I have
ahead.
to interrupt. Like, when you mean dialogue goes nowhere, like if it's an active inquiry, I'll feel like that's you didn't say this, but I have to say it's still just as meaningful. Like,
Okay.
for example, in math, when you play around trying to prove something, uh, quite often it'll go nowhere. It's like experimental, but you know where
Uh,
not to go. It's super useful.
okay.
Yeah.
So maybe not go nowhere in the sense that it didn't produce anything of meaning, but that you at least had some experience playing around, and that it produced
Hmm.
nothing of meaning is the useful result.
Yes.
Um,
Yeah.
so a symptom that I seem to experience with this is feeling like I know or can justify or verify nothing. I'll be in a conversation with somebody and they'll bring something up, and I'm like, oh, well, yeah, that could be right. That could be true, but
Do you have sufficiently powerful
yeah,
axioms?
right. And then I internally don't know if I have sufficiently powerful axioms. So I guess that might be a good question: is what's a good way that we can tell, or what's good feedback look like when we're asking like, are my axioms sufficient? What does that look like?
Um, uh, let's see. So I'll just preface this. Will, I'm still trying to figure out what my
Yeah,
axioms are. Um, so what good feedback looks like? I'll just tell you the philosophy I've been trying to
sure.
construct around what good axioms are, and then maybe how to find them. Um, personally, I think good axioms are. This is gonna sound like trees are made of trees type statement, but good axioms are axioms that coincide with your biology, with your health. So, an axiom is healthy for you, not unhealthy. And I'm being very vague with health here.
Right,
It
right.
doesn't like don't interpret too literally like uh, health in the sense that amplifies you, like your vitality,
I see.
your being. Yes.
And we can maybe an example of this could be like, well, one of my fundamental axioms is that oh, I don't know, I don't like sunlight, and you want to be a vampire and sit inside all day, and the result of that is, well, you know, your adenosine levels suck because they're through the roof because you don't get enough sunlight. So you might have a system that's robust, but should we be questioning what the output of that is, and analyzing the? And I know you said not to worry
Yes.
about like physical health, but in
Hmm.
terms of like our vitality, it's
Physical
the
health is
usefulness.
definitely part of it.
Okay.
Yeah.
So do we construct systems, or should we construct systems because they're useful or because they're true?
Yeah, remember how I said like, okay, we chose the Piaget's axioms because it's so intuitive to us that 1 + 1 is 2. It's almost like a universal rule. I think quite often when people are discussing philosophy around like how you should, like what axioms you should predicate your philosophy on, I think people forget that like, okay, in the same sense that 1 + 1 = 2, there's this obvious notion of us being humans, biological humans living in this world. So uh, you do kind of want to orient your axioms around that in some way. So, like for example, certain axioms, are very counterintuitive to being a human. So
Hmm.
this is again to a bit more of the philosophical hot take
Yeah,
territory, but
yeah,
this is actually like kind of a Nietzschean thing, and like a criticism along this line would be like ascetism gone too far, so like forsaking worldly things for the sake of uh, for the sake of some sort of promise in another world. That's typically not very healthy if it's
yeah.
like you're starving yourself
Right,
so you
right.
can achieve nirvana. You know, like that one
Sure.
monk practice
Yeah,
that
yeah, where you sit under
got
a tree
banned.
for like, weeks on end and starve yourself. So,
Yeah.
so our axioms need to be something that produces results that are healthy and flourishing to us in the life that we're in
Mhm.
now, and not so that might be a good way to test. Is what I'm doing producing healthy results for me? And I mean that's a pretty. I mean if you're just honest with yourself, then that can be a pretty simple question to answer. So yeah,
Yeah, yeah. Like, don't choose an axiom, which is I always go to bed at different times.
yeah, yeah. I've me going to bed last night at 4, but no worries,
Yeah, nice job.
we'll
Yep.
get there. So you also mentioned that we want to construct a set of axioms that are applicable to the real world because yes, it's true that 1 plus 1 is intuitively 2, but we don't want to just construct ourselves some mathematical fantasy land where there's nothing that we can read across into the real world. I mean, the reason
Hmm.
why it's obvious that 1 plus 1 equals 2 is because some dude had one rock and another rock and was
Hmm.
like, that's clearly two rocks. And there's something physical going on there. So can we fall into a trap of creating these just like pompous mathematical axioms that give us no bearing on the physical world or maybe aren't useful in that sense? That's a common critique of math. It's like, oh, this grad student's doing this like hyper specific mathematical thing, and it's like numbers don't even exist, man. Like, what's going on here?
Yeah, or like string theory. Not that I know,
Yeah, string theory is the great example.
not that I know anything about
I don't
string
either.
theory, but
No, there's 11 brains, or there's bulks in brains, and none of them are real. So
mhm. Yeah, yeah. So sorry, what was the question?
The question was, can we fall into a trap of constructing an axiomatic system that has no bearing on the physical world in terms of results? Or maybe the answer to that is yes, we can, but how can we avoid that?
Yeah, well, I think what we actually kind of already covered how
Yeah,
is that you make sure it does have like the axioms do have a significant bearing on the real world. Like they're robust enough to kind of model whatever you're seeking as a solution in the real tangible world, right? So um, if you design your axioms completely independent of reality, they're not going to be very useful for reality. Um, so if instead of 1 plus 1 equals 2, we chose to create some really weird number system where all the numbers are equal to 0 or something. That's,
yeah.
you could do that
I'll give you
probably.
0 bananas for my 0 bananas.
Yes, yeah,
I think we did that in Catan yesterday.
yeah, yeah. So you could, I believe you could like axiomatically design the natural numbers so that they're all equal to 0, but what's the use in that? This would be a valid system you can kind of explore if you design the axioms correctly.
I see.
Careful with the word valid, but
Right, right.
um,
Verifiable.
yeah.
So I wanted to ask about Gödel's incompleteness theorem.
Mhm.
This seems to be like a hot topic thing, and anytime axioms comes up, it's always like incompleteness makes its way into there. I know very little about incompleteness theorem. I know there's things called Gödel numbers, and there's some wait, but I don't understand what's going on and what's all the buzz about incompleteness. Why is that such a powerful thing?
Yeah. So I'm gonna preface this and say I've never actually done the mathematical proofs of Gödel's incompleteness theorem. So because of that, my expertise is going to be limited. However,
Sure.
I do understand a little bit. I think we're about to see the Dunning-Kruger effect. So, uh, yeah. So Gödel's incompleteness theorem. I was getting at this earlier. It has three components. If, you're discussing an axiomatic system. So the three are uh, consistency. So there's in the axiomatic system, there aren't propositions, statements that are both true and false. That's a broken system. We don't want to use that. That's one part. The second part is that it's robust enough. It's sufficiently powerful
Okay.
in the sense that it allows you to do useful things like arithmetic and multiplication and whatnot. But more generally, like this just holds for propositions. Like I don't know how sufficiently powerful works if you're like not really working with math anymore, but uh, just take this as the idea is it needs to be sufficiently powerful. Like the axioms need to be able to do a lot, like derive meaningful results pretty much. And then the third, I believe, is it's you can you can use a countable amount of axioms to create the system. So
So you don't
you
want to
can
swamp yourself.
yeah, you can well by countable I mean like countably infinite.
Oh,
So
okay, okay, yeah,
I'm pretty sure.
like the
So
naturals.
yeah,
Okay,
yeah. So like one, two, three, four.
yeah.
Yeah. So I might be wrong, but the yeah you this is to prevent like pathological systems. So
Yeah.
if you can maybe say, okay, I have like a ridiculous amount of infinite axioms, and each of them do this thing, it can kind of like create really weird
Kind of
results.
sounds like the bureaucratic state, and
um,
a little bit. I don't know.
maybe,
But
yeah.
so
Uh, oh yeah, so I didn't actually explain what Gödel's incompleteness
yeah,
theorem was.
where's the incompleteness?
Yeah,
This
so
sounds great, but does it
having
fail?
these things, so if it's consistent, if it's sufficiently powerful and it's axiomatizable, okay. Gödel's incompleteness theorem comes up here, the second theorem, and uh, basically it says that you're guaranteed to arrive at statements that you can't verify within the system. It's like if you have the axioms and the axioms are building up the propositions, there will be some statement that is like, well, not problematic, but for most people, existentially problematic in the sense that you can't verify it to be true or false. And as a consequence of this, I'm going to say that uh, if you have a system with axioms, you can't actually verify that the axioms themselves are true within the system. Um, you would need to introduce another axiom to do that. So that's basically to say that like your truth values are defined within the system you created, and you
Okay.
can't define them outside of the
So
system you
we can't
created.
seek to verify the system that we use to create the methods of verification.
Yes, you would have to introduce another axiom outside of the system,
Yeah.
which then creates another
And
system.
then you get this infinite regression effect, and I imagine that would trash the third postulate of Gödel. You need
Uh,
to have a countable. I mean,
uh,
if you just introduce a new axiom every single time
well, that
you
is
want to verify.
countably infinite. Like
Oh,
you
it
have
still
one,
is?
two, three,
Okay.
four. Yeah.
Yeah,
So,
it's be muddy for sure.
yeah, the thing is, like, if you have a system predicated on certain axioms and you've built up to this point, the idea is like, or what you could do is you could then introduce another axiom, which basically expands the domain of what you can
I see.
prove.
Like a new
Um,
tool.
yeah, pretty much to say, okay, well, this proposition we encountered, which we can't really prove, let's make it so we can prove it one way or another. And then let's continue building up until you encounter the same thing. So you have a system from axioms, then you expand it and expand it more.
Right.
That's the idea. It's an inductive process.
This seems, I mean, the immediate similarity I draw to is like sort of the agnostic position where I can't know, where I have, say, I'm going to go full philosophical here.
Yes.
So, God comes down and stands in front of me and says, I am God. And
Hmm.
we don't have the tools available to verify if that's the case or not. It could be true, it could not
Hmm.
be true. But because that's something that is sort of definitionally outside of the realm of what we can access, we simply don't have the toolkit to verify that. And
Yes.
to me, the takeaway I get from Gödel's incompleteness theorem is that this is a mathematical proof that demonstrates this.
Uh,
Is that accurate to say?
yeah, so um, I don't know because I haven't done the mathematical
Sure,
proofs,
right.
but
But in theory,
I remember I jokingly told you like God is the n plus first axiom
yeah.
expansion. So like if you've expanded the system by supporting the axioms with a new axiom like n number of times, then God would be the n plus first. He's outside of the system demonstrating the proof of the system.
Always
Uh,
at every single
mhm,
time you try to introduce. So does that is that a necessary thing? I mean, the whole point of us setting axioms in the first place was to have some starting point, and that
mhm.
required somebody to make a starting point. So, I mean, does this demonstrate the necessity of some n plus one thing to say, okay, yeah, the system exists?
Uh, necessity? I mean, okay, like the axioms emerge from motivation. If you want to verify the axioms are true, then there is a necessity to have another axiom.
Yeah.
You can't ever say that the entire system with the new axiom included is also true, because you'd have to define another system in which
Yeah.
it's true.
That's the n plus one, right? Where,
Yeah,
yeah.
yep. It has to be inductive.
So the truth value of any of the conclusions of the system are fully defined by the system itself, and you can't seek to externally verify that.
Yes, that's correct. Unless by external verification, it's introducing another axiom. Yeah.
Well, but even that's not external in the sense that you just have a new system with another internal axiom.
Yeah.
So it's like a
Yeah.
subsystem that you can verify.
Yeah. So here's where the existential dread sets in.
Okay, yeah, right. I mean, this might be
Yeah.
the purpose of like a functioning government even is you have
Mhm.
enough people that agree on some concept and they have enough ways to internally verify it. But really, there could be that one guy who goes, "Oh, I reject all of this," and goes and lives in the woods. And it's like, yeah, we can't say that he's wrong, but you're no longer able to participate in this thing that we've built, and sort of everyone needs to agree and participate in this structure for it to have any
Well,
value.
a better example, if people have heard of Terence Howard,
Yeah.
yeah, that's a great
So is that
example.
what he's
Sorry, not
doing?
to derail what you're
No,
saying,
no,
but
no. That's
yeah,
perfect.
that is what he's doing. Is it's not that he's wrong within our system. The
Yeah.
problem is he decided to use our definitions, but then use different axioms. So sure, you
Mm,
can define the square root of 2 to be 1, but that's not how we defined it. Like if you take 1 times 1, that equals 1, which is not 2.
right.
You need 1 times 1 to equal 2 for the square root of 2 to equal 1.
So is the issue that he's running into in his explanations is that he's trying to take some system that he's created and cram it into the rules of a system that it doesn't allow for, and
Yes.
and then the argument there becomes, well, that's not true, that's not correct, and it's like, well, we have to keep in mind that the truth value or the correctness of this is confined to the system with its when it, that it exists in, and we can't
Yes.
just shove something else into that.
The systems that Terence Howard and I guess everyone else are using are disjoint. So, um, but the thing is, he's using the definitions that we're using,
Mhm.
and he's conflating that with like having the same axiomatic meaning or the same axiomatic formalism implying his definitions. He's trying to say that there are contradictions, but there aren't because we're just not using the same axioms.
I see. And of course, it would seem if there's contradictions if you impose a new system on an existing system and try to conflate the truth value of those two
Yeah,
systems. So,
he created an inconsistent system.
oh, so there's flaws within it. So I guess maybe there is a use case where we do want to create a new system, but there has
Yes.
to be some value that comes out of that. And
Hmm.
maybe this is the entire scientific enterprise.
Yeah, it is. A great example is Euclidean geometry. We mentioned that earlier.
Hmm.
There's different axioms like reflexivity, and then another one which is like it's
Transitivity, is that?
the whole is always greater than the part.
Oh, I see.
That's another axiom that Euclid has. It's basically like zero point 0.5 is always less than 1 because it's half of the thing.
Sure.
Anyways, so we have all of Euclidean geometry in Euclid's 13 books. We created a more general system because we saw something very interesting there. There's an axiom in Euclidean geometry. And this isn't how he states it, but it's equivalent. Basically, the axiom is if you have a line and a point not and another point. So if you have a line and a point, then there is exactly one other line that you can put on that point such that the two lines are parallel. Okay, so this is an axiom of Euclid's. Does this make sense?
Is what you're saying you have a line and then you have a point not on the line, and then we can place another line running through that other point such that those two lines are parallel?
Yes, and
Okay.
there's only one other line that can do
What
that.
if the space is
One.
curved? Never
Yeah,
mind.
well, exactly.
Oh, is that
So,
really
yeah,
the
you take the negation of that statement, and suddenly you're saying, okay, well, either there's no lines that can be parallel, or
right,
there's more than one.
right.
Um,
And by
and
curved, I just mean like, we might it might appear that two
mhm,
railway lines are parallel, but if you look off in the distance, they seem to merge. And same
mhm.
if I took two lines of, I guess, longitude, then locally they're parallel, but if you follow them around the globe, then they will intersect at some point.
Yeah, yeah. So if you take the negation of this axiom and use all of Euclid's other axioms, you get like hyperbolic and elliptical geometry, which is what you think of as like when you're talking about curved spacetime with general relativity,
Yeah,
you're using some of these concepts. So as far as like expanding a system to be useful, people have like after Euclid's Elements, we created a more general geometry to accommodate for the other types of geometries other than Euclidean
right.
geometry, like this hyperbolic geometry and this elliptical geometry, and there are other geometries too, geometry everywhere.
Yeah, I mean, this typically, if you go through any mathematics course or you maybe get through
Mhm.
Calc 3, you get introduced to some coordinate systems that are beyond our simple Cartesian X, Y, and Z. And then, you get your spherical coordinates and you get your cylindrical coordinates. Those are sort of the two, like, this is your toolkit, and you can evaluate most problems with these three coordinate systems. And then maybe you get one class later and you're like, hold on, there's actually
those
27
those
coordinate
all
systems.
operate Euclidean
Oh,
and
those are
Euclidean
all still
geometry.
just extensions of Euclidean
Yeah.
space. Okay.
Yes.
So I'm in a general relativity course right now.
Yes.
It's very fun. And if we're on the topic of curved spacetime, I wanted to ask, when Einstein introduced general relativity, I think, was it 1906?
Oh no.
Oh man.
GR no later. That's SR, special
Oh, that's
relativity.
right. Yeah,
Yeah.
that's right. Um, it encounters a lot of resistance. Does it encounter resistance in the community because it presents this like sort of groundbreaking idea that seems to go against the conventional wisdom of these axioms? And it might be a logical extension of them, but it's just so taboo that I think
Wait.
Cantor encountered this too when he tried to prove the naturals.
Yeah, so that's an interesting story, by the way.
Yeah.
But what do you mean encountered resistance? Like at the time when GR was published?
Well, I don't know if he published his solutions. Well, he didn't. I'm sorry, he didn't have solutions to his field equations. He published the field equations, and well,
Hmm.
hopefully someone finds a solution. People did, but maybe specifically with Cantor, his ideas encountered a ton of resistance. So
Yeah, yeah. By the way, I'm just going to explain what Cantor's ideas were. They're
sure,
very, it's,
yeah, you'd
I
be
think
much
I
better
can
at that
make
than
it
I am.
simple. Okay, this won't be everything of his, of course, but the simple idea is you have sets. So sets are just like like a bag, like a mathematical object, like a container, and a set contains things in the set. So the natural numbers are a set that contain 1, 2, 3, 4, 5, 6,
Mhm.
and so on. Um, Now, there's this concept of asking how many things does the set contain? So the set of the number 3, Barack Obama, and the color blue, it contains 3 things. Not 4, not 5, 3. Now, the natural numbers, uh, they contain a countably infinite number of things. Um, what Cantor said, or sorry, yeah, what Cantor said is the cardinality of sets being equal is basically like how you can define how much,
Cardinality
or
is the one-to-one
sorry,
mapping,
the
right?
the number of things in the set.
So
Yeah,
it's my
that's
understanding
the
that if
cardinality.
oh, okay,
Yeah.
wait, so the number of things. So we say two sets are cardinal if they contain the same number of things.
The cardinality of two sets is equal if the number of things in each set is equal.
I see. Okay.
Yeah, so Cantor introduced the idea of like countably infinite and uncountably infinite. And basically countably infinite is if something has if you produce a number of things and it's infinite, but if you take the set of those things, if you take the cardinality of the set of those things, that cardinality is equal to the natural numbers. And
I see.
it's uncountably infinite if the cardinality of whatever you're producing is like greater than the
Because you
natural
basically
numbers.
just said you have an infinity which is larger than another one.
Yes,
So
so
is that was that the point of
some infinities are larger than others.
right?
Yeah.
And was this what Cantor encountered in terms of resistance, where people were like, okay, this is rubbish, and it's a logical extension of the axioms, but it just seems so preposterous that it didn't get thrown
Mhm.
out. I mean, obviously it stuck, but at the time he went through a lot.
He was ready to throw hands, man. He went to a mental asylum. It was
Goodness.
yeah, it was brutal. And yeah, he encountered a lot of resistance here because if someone's hearing, okay, there are different sizes of infinity, and you can, I just explained a bit of the mathematics
Right, right,
behind it.
right. I mean,
Like
it sounds insane,
yeah,
but I guess it's a logical extension of the set of axioms we've used to construct things like the natural numbers and other
yes.
sets. So,
And it used objects we already have with
right.
our other axioms, is the cool thing, right? So he used the natural numbers, which we already have.
So I have a question.
Yeah.
Did he have to, earlier we talked about, okay, if we have this thing we want to verify, we might have to introduce a new axiom that expands the system so we can verify it. Did he
Mhm.
have to do that, or did he just arrange these axioms we already had in a way that's like, look what the result is?
Yeah.
Because I could imagine there's a lot of resistance if you just, spring up some new axiom that can verify your proposition, because there's probably some resistance to just new axioms coming up all over the place. But did he have to do that?
Okay, so I don't quote me on this,
Sure, sure, sure.
but I don't think so. And the reason I say that kind of confidently versus not confidently is I've done the proofs for
Ah,
these. So what he did is he just created a um, okay, I don't want to use too many math terms, but he created a mapping, like a bijective mapping between
ah,
the natural numbers and other things, and that demonstrates the things are like equal in terms of size.
okay.
So
Okay.
he didn't have to use any axioms. He used like mathematical objects we already had, like the natural
Yeah.
numbers and the real numbers, and like you can say that things have an equal size if you can create a mapping between like one object in one set and one object in the other.
So he took a system that we have
Hmm.
and took the logical extension of that system to show that there's like these absurd realities that exist. The idea that one infinity might be larger than the other, whatever
Yes.
that means. And it
By the
drove
way,
him,
that starts to get like there are some infinities which we don't know whether they're larger than others, and I
it's
think
not
that's actually
verifiable.
an example of yeah, you can't verify whether it's true or false.
Gotcha.
Yeah.
So his findings were so outlandish it drove him to a mental asylum and gave him a bunch of trouble. Is he
Well,
the Nietzsche of math? Is that what's going on?
um, okay, so I think part of what yeah, once again, like, okay, I'm getting back into territory I don't know too much about, but
Sure.
I'm pretty
I'm
sure,
always there.
I suspect that what made him struggle so much mentally is like being ostracized by the
Sure.
math community.
Yeah.
Like, that's a super difficult thing when you're ostracized by society, and that's what happened to Nietzsche.
Yes, it
So,
is.
in
Yes,
that
it is.
sense, it does look like they're very similar. Yeah.
But we need these people to spring
Uh,
fields
mhm,
forward. I mean, contributions of philosophy from Nietzsche are
mhm.
huge and will be studied forever. And I assume the same of Cantor, at least in the math field. So, is this a sort of cycle that that's a self-correcting cycle that comes out of a good set of axioms? That might be another way to test it. Is like every now and then we get this person that comes in and arranges things in such a way that seems so preposterous, but it's a logical extension and it follows. And yeah, it's going to upset some people, but it's making progress. And then 80 years later, 60 years later, we're like, okay, we're okay with it now. But so maybe well, I don't think Terence Howard is a good example because he's not using the system that already exists. But
Yes.
But can we be more open to people who come in and take what we have, arrange them in new ways that might seem preposterous?
Uh, that's just it's paying the piper, right? That's the cost of the axioms you
Yeah.
chose. And if they can prove it, then yeah, you have to accept it pretty much. Or you have to say, okay, I don't like these axioms anymore,
And you
but
just remove yourself from the system, and yeah.
yeah, but that could be problematic if you're
Yes,
saying
it can.
I don't like, the basic axioms we
Yeah.
use for
You might be able to get away
mathematics.
with it with math and go back to just being like 3 bananas, 4 bananas, 7 bananas. But
Uh,
I mean,
yeah.
existing in the world, I mean, but if we're
Mhm.
dealing with an axiomatic system that is not a rigorously mathematically defined one, yes, you're going to encounter a lot of problems if you just, and this is, I mean, I think of the example of religion, of
Mhm.
institutionalized religion. It's sort of a set of axioms that you almost get, if you were raised religious, you get handed a set of axioms. And if you reject that, then yeah, you can get yourself into not trouble, but more mentally having to sort through all these things that's going on and maybe construct axioms for yourself and see how those play with the ones that you've been given.
Yeah.
And in a sense, that's what I'm doing here. So
Mhm. Yeah, when you start to play around with the axioms, it can kind of be uh, like it can feel kind of like you don't have solid ground anywhere.
that's
Like,
exactly how it feels.
yeah,
Yeah.
it's like you're trying to build your house on sand or figure out where there's rock underneath
Yeah.
the
Figure out
sand.
where there's rock is definitely
Yeah,
where it is.
it can be quite challenging. I mean, like if you think about um, axioms in this way, like it can be really unnerving. Like when you
Yeah.
combine like Girl's incompleteness theorem with like, okay, well, let's ask like what axioms we want to believe. That's an existential crisis for sure.
Yeah.
As far as like having these religious axioms and then maybe having to question them for their validity, right? That's basically what like you're doing is like you're
Right.
playing around with them. You want to determine whether they're really meaningful axioms that you want to hold on to. Uh, that I mean, sorry. Yeah, that makes.
Well, I guess this
Sorry.
is no, no,
Yeah.
no. I think this is earlier. I had just mentioned that every now and then you need someone to come along and sort of arrange the axioms in a way
Hmm.
that's so profound. I mean, this might be kind of what's happening when a church or religious system bifurcates into two systems, and you get like the Lutheran Church splits
Hmm.
off, or you get the Latter Day Saints who came in and said, well, we're going to rearrange things in this way that seems to produce better logical extensions, and then you get camps of people. So
Hmm. Yeah. So. Well, that's an interesting topic because like you have to ask, is the bifurcation because of the axioms, or are the axioms bifurcating because the church is
yeah,
bifurcated, right?
yeah, could be
So
power play.
yeah, it could be a lot of things, but I know I've discussed this with you a bit, is like the idea of memes. So like
Yeah,
religions
love
are
memes.
super complex memes. We're talking about Richard
Yes,
Dawkins memes here.
specifically the taking the idea of natural selection and applying it onto ideas and saying that
Yes.
ideas evolve. This is Richard Dawkins' selfish gene idea.
Hmm.
I have the book sitting on my nightstand and I haven't read it yet because I have this really big book that's in the way that I still have 200 pages left in. But
Hmm.
I'll get to it soon, so I'll know more about that.
Yeah, we'll use the naive definition of
Right,
memes. Yep.
right.
But that's the basic definition. And like if you kind of understand this, well, okay, a bifurcation in churches, if it's a bit more natural, like religiously, so like um, Eastern Orthodox versus Catholic.
Right. Well, I don't. Was that
Well,
natural?
no,
No,
actually, that's
Henry
pretty
VIII was like,
politically
I
imposed.
want to divorce my wife. I think that was the.
Eastern or no, that would be
Oh,
Protestant.
that was the
So
Church of England.
Eastern
Yeah. Oops.
Orthodox versus Catholic, I believe, emerges from one of the Justinians in Byzantium, basically deciding on issues involving the biblical interpretation. And
I
like
see.
there's kind of a clash there between him and the Pope. The Pope for a while was trying to get into Byzantium's DMs and try and invite them back into the church, but they just never did it. Yeah, so I think that's where it comes from, is
Okay.
like this like the bifurcation between like the Pope and some of the patriarchs in Byzantium, and like and the capital of Israel.
Yeah.
Jerusalem,
Yes,
yeah,
yes, yes.
and other places, yeah. Um, yeah, but like as far as like religions bifurcating, sometimes it can be from a bifurcation in axioms, but that's like kind of hidden behind the
Yeah.
memes
Like
like being
there's a
different.
motivation that's I mean, this might be what we were talking about when we have dialogue with somebody and we don't start from the axioms, is that, well, our conclusions have led us to want something out of this in a way that we're not going to do it axiomatically. Like there's some motivation that's superseding the axioms, and that can be dangerous.
Well, I'll tell you what's happening is if you are motivated to maybe not explore the axioms, it's because um, when you try to explore what happens when you tear down the axioms which you kind of predicate your life and the way you operate on, like when you explore the abyss that emerges from
Yeah.
like an infinite amount of options and no clear foundation, that's terrifying, like absolutely terrifying, because the novelty is just way too much. And that's why I think um, depending on the person, there's a lesser or greater tolerance to how much they're willing to play with their axioms. And
Yeah.
if the tolerance is lower, they're maybe not going to produce as good of a dialogue. Yeah, that's what I suspect at least. So
Right.
it's kind of psychological.
I'll get back to you once I take my philosophical psychology course next
Oh, of
semester. If
course.
I take that, that would
Yeah.
be nice to take. But
Yeah.
yeah, well, I feel like this has been a productive conversation.
Hmm.
So thanks very much. Very nice.
Yes. All right. Bye bye.
Hopefully you enjoyed today's conversation, and if you have any thoughts about our discussion, please feel free to leave them in the comments down below. Do keep in mind this is episode 0, or the pilot episode of this show. I've never done anything like this. I bought these mics like last week, maybe, and things will get better. The audio quality, the video quality will get better. I do have more guests coming on, and I plan to be shooting another one of these in a week from today. So feel free to subscribe and look forward to that conversation. Thanks. Okay, well, we'll see. I think us editing.